All right, in this next problem, number 3 example, it says we have a recipe and there are 4 ingredients. You can have flour, baking powder, shortening, and milk, and they label them with the capitals. There are no directions for the order that you're supposed to start, which is frustrating. Chris has never followed a recipe like this before and has no idea. So he's going to choose from random. And they want to know how many different possibilities are there. So if I were picking one, how many choices are there when I pick my first thing? 4. There are 4 things, I got 4 choices. I take that choice out. So let's say I take out the flour. Boom, gone. How many choices are left now? 3. I take out the next thing, which was the baking powder. Then there are 2 choices, and then there are 1 choices. Which means if you're trying to figure out how many different possibilities are there in order, you would get a total of 24 ways you could start mixing these things together. That's a lot of ways for just 4 ingredients. Then the second thing says, what's the likelihood that milk is going to be first? So when you look at that, what ends up happening is when you're talking about milk being first, I know if I'm choosing milk first, there's only one way I can do that. Right? You have to pick the milk first. There's no choice. Then, how many ingredients are left over? 3, and then 2, and then 1. So this is a total of 6 ways that you could be picking things where milk has to be first. Okay, 6 ways where milk is first. But that's not the answer to the question. Okay, so it says picking milk first. So if I was going to pick milk first, after you know that there are 6 possibilities in which if you pick milk first, you could rearrange all the other things, what they're telling you is, in order to figure out your likelihood of that happening, there are 6 ways you can do that milk stuff out of the 24 ways you could have arranged everything in the very beginning. So, really, when you simplify that, there's a 1 in 4 chance, or a quarter chance, that when you pick milk first, that's what's going to happen. There's a 1 in 4 chance that you do that. 6 things out of the 24. Way to do a problem. Okay, so what's the likelihood that the correct order includes flour first and shortening second? So this is similar to the previous question. If I want to pick the flour first, I don't have a choice. You have to pick flour first. There's only one way to do that. It tells you that you have to pick shortening second. You don't have any choice there. Boom, done. There's only one way you can do that. They tell you what you have to pick. But then there are 2 things left over. So there are 2 choices here and 1 choice here left over with the 2 remaining ingredients. I can pick one first or the other. But then the last one's automatic. That means there's a total of 2 ways that this could happen. And if you want the likelihood that you're going to do this in this order out of the total possibilities, you would say that I have a 2 in 24 chance of that happening. And all these 24s are coming from the total number of possibilities that we started with. And of course you would write this in a simplified format, which is a 1 in 12 chance that can happen. What about the probability that in letter D, you have to go flour first and then baking soda second, so on and so forth? You have to do it that way. What's the chance that that's going to happen? 1 in 24. You don't really have a choice. There's only one way you can make that happen out of the 24 possibilities. Done. They tell you the order, end of story, but there were 24 ways you could have done it. What's the likelihood that that's going to happen? 1. Just 1 out of the 24. And what about, what's the likelihood that it's not going to be that then? Excellent. 23 out of 24. So 23, which is the ways that are left over, out of the 24 ways that you could have done it, is when it's not going to be the F, B, S, M. In the last example, the Postal Service introduced zip codes. And what you might not know is now there's another 4-digit zip code after your 5-digit zip code. So like, I live in Hopkins, my zip code's 55343, but then there's another 4 digits after that. So in 1963, they introduced it to help process the mail efficiently, and usually you have 5 digits. So we're going to ignore the last 4 for right now. And they want to know how many zip codes are possible then in the United States of America. So here's what you do. For the first number, 0 through 9, how many choices could you pick? 10. You can pick 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 different numbers you could pick. Can you have more than one number in a row? Can you go 5, 5? For sure you can, because we do it right here for all of you who live in Minnetonka, Hopkins. I think Golden Valley has a 5, 5, doesn't it?
Yeah.
So there are 10 again. In fact, there are no restrictions about you can't have a digit more than once, or you can't have it for all 5 digits. So there are 10 possibilities for every single digit in your zip code. So you multiply those all together. Next one.
You didn't answer the first
Oh, I'm sorry. What's the first one?
10,000.
There are 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. I'm going to say 100,000.
Right.
When you multiply it out. And the next one, here's where they talk about that 4-digit extra zip code. So this is almost exactly like letter A, except now instead of being 5 spaces, there are 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And each one has 10 possibilities, just like the previous, because you can put a number 0 through 9. That means there are going to be 9 zeros. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is 1 billion. 1 billion possibilities. In Canada, they do things a little bit differently. They use 6 different things, and they do letter, digit, letter, digit, letter, digit. So they go every other one. So as you're looking at that, that's kind of a different story. And if I'm looking at letter, how many letters are there? 26. And then there's a digit, so that's 10. And then a letter, and then a digit, and then a letter, and then a digit. And if I multiply that out, I get this number. Which is 17,576,000. So we have 1 billion in the United States, and they only have 17 million. And before, we used to only have 100,000. So we have definitely improved our tracking method in our country for mailing things out. Way better than we did before. And Canada, probably because it has a much more sparse population than the United States, probably doesn't need as many zip codes as we do, so they're still only in the millions. Okay, so in letter D, they throw some more specifics at us. They still have 6 blanks, 1, 2, 3, 4, 5, 6, but now they tell us that when you're talking about the first characters, which are here and here, we know that in the first characters, we don't use WZ, and we also don't use D, F, I, O, Q, and U. So how many different letters are subtracted out of the first possibility?
8.
How many?
8.
8. And I think I highlighted a little bit too far, because it said first character, right? So that's gone. So in the first character, I know that I have to take 8 away from 26, so that means I only have 18 possibilities for the first character. And then the second one is not affected because it's a digit. In fact, none of the digits are affected. So I could write down a 10 here, a 10 here, and a 10 here because the digits are not affected. And then in the last two, the only thing that's affecting those two is the fact that I'm not going to be using D, F, I, O, Q, and U, which is a total of 6 things that means that the other two slots have a possibility of 20 letters. 26 minus 6 letters that you can't use highlighted in yellow makes 20 left over for the other ones. Can't use 6 letters. And if I multiply that out, I get 7,200,000 different possibilities that I could have. So in the light blue, this is really what the likelihood is, but reality is that the Canadian government only really has less than half of those possibilities because they don't use certain letters.